Hello and welcome to Maths with Mr Amison. In this video I'll be going through a goal-free problem to do with angles in polygons. If you need a recap of how angles work in polygons, then please watch these videos here or follow the links in the description below. So I'm going to give you this problem. I'm going to give you a moment to pause and so have a go at finding out anything you can about this shape here. Alright, so in this example, there's a number of things we can notice. We can notice that this general shape is a regular pentagon. Okay? It has to be regular because of these lines of symmetry. It means that this line is the same length as this line. This angle is the same as this one. This angle is the same as this one. But also, this angle is the same as this one because of this line of symmetry. You can see that this is a regular shape because of the lines of symmetry. The sum of the interior angles of a regular pentagon is 540 degrees. That helps us because it means we can now calculate the size of the interior angle. Or we could have done 360 divided by 5 to get the exterior angle, and then done 180, subtract that to get 108 degrees as our interior angle. We should also recognise that if this is a line of symmetry and these are straight sides, that means these are 90 degrees on each side, here and here. Okay? Because this is a straight line, these have to be 90 degrees. We also recognise that if this angle is 108 degrees, then each side of the angle, because of the line of symmetry, must be 54 degrees. And we can see that we have four shapes that the pentagon is split up into: a quadrilateral, two triangles, and another pentagon. At this point, you can figure out a number of things. You can calculate these angles to both be 144 degrees by either calculating the fact that this has to be 144 because of the 360, this has to be 144 because of the 540, and they're vertically opposite each other, so they must be the same. Similarly, we can figure out these have to be 36 degrees, either because of 180 degrees in a triangle, or by the fact that they are vertically opposite as well, or that these are straight lines, so they have to add up to 180. There's another thing we could calculate here, that's these angles here, they're 126 degrees. This angle would also be 126 degrees thanks to the line of symmetry. And as well, these angles here are also 90 degrees, both sides of the line of symmetry again. Now to introduce you to what the question was for this particular question, exterior angles we already covered. In this question, the actual question said work out the size of the angle marked X, which was this angle here, and we could have done that without doing so much, of course. The way we could have calculated that, we could have just used this part of our diagram, recognizing the 108 degrees first, the 90 degrees second, and then we could use the 540 in the pentagon. Or we could have used this quadrilateral and used the fact that 144 was vertically opposite this one. Or we could have used one of the triangles and recognise that the 36 and the 144 make a straight line. So there's a number of ways we could have approached this question to figure out the size of the angle marked X. I hope you found that useful. Thanks for watching. Speak to you soon.